some of the details of transmission. So details of transmission we really need to understand, right? Um, so uh, so so let us do something. Let us try to understand how the data transfer actually takes place, right? So I already told you at the conceptual level in the previous lectures. First of all, how to form the networks. What are the different types of topologies, and then we looked into, like, what are the different possible ways in which, if a particular switch receives some information, some data, some message, how it is going to send across. So we have seen like different switching techniques, right? Now the question is that how this message, each of these messages, how this data, how does the data look like? So actually the data that is passing through, between these different computers, how does it look like, right? So there are different types of, so if you are talking about the communication network, right? If you are talking about the communication network, so you can have different types of signals. You can have two types of signals. You can have two types of signals. You can have an analog signal passing across, or you can have digital signal, right? So you can, in fact, you can have digital data, you can have analog data, and in terms of signal, you can have digital signal, you can have analog signal. So ultimately, if you are thinking about these cables, etc., these cables, whether it is cables or whether it is the air medium for wireless communication. So these media, they are going to carry certain signals. Okay. So how you are going to send these different signals is what we need to really understand. We need to really understand how these signals are going to be sent across. So let us try to first understand the different types of data. So one, as I told you, is the analog data. The other one is the digital data. Analog data basically refers to information that is continuous, right? This, I think, most of you by now, you have done some basic courses so far. So you must be able to know what are the different types of analog data. The same thing for the digital data also. So here actually this data will take some discrete values, discrete states, right? And on the other side, we can have this analog signal and the digital signal. Okay. So analog signal basically looks like, these are like, these analog signals. So analog signals basically, so I think like a sine wave, for example, is a representation of the analog signal, and digital signals basically in the form of zeros and ones, right? So level 1, level 2. Okay. So digital signals can be sent in that manner, right? So zeros and ones, right? So this is how you are going to send. So level 1 means, like, let us say that low voltage will be level 1 and high voltage could be level 2. Like, let us say 0 volt for 0 and plus 5 volts for let us say 1, and so on. So like that actually this kind of digital signals can be sent across, right? So you have analog signals and you have digital signals. Okay. Now analog signals basically can be even like periodic or non-periodic, etc. So these things basically, whatever you have learned during your physics classes in +2 or even after that, so those kind of concepts basically are required in order to understand the analog signals. So let us not get too much into those, because those are things that you can really understand or you already know, or you can understand on your own. But let us try to understand that in the context of computer networks, how this communication is going to take place. Okay. So if you are talking about two devices, okay, maybe one is a server, the other one is a desktop computer, let us say. So if you are talking about communication between two devices, there are three different types of data flows that can happen. three different types. One is called the simplex, the second is called the half duplex, and the third one is called the full duplex. So look at the figure in front of you. So the first one is the simplex, second one is the half duplex, and the third one is the full duplex. So these three terms you will be encountering quite often in not only this course, but if you take up a career in communication networks, these are the terms that will become the bread and butter for you. These terms you should really understand very well. So what is this simplex? So simplex, in simplex communication, the sender device sends some message to the destination node along a certain path in a certain direction, right? And this is kind of like a one-way street. It is like a one-way street. So you see that the mainframe computer on this particular in this particular figure, the mainframe computer sends some message to the monitor. Okay, the direction of data, as you can see over here, this is the direction of the data. So this is simplex connection. Okay, you have a unidirectional flow of all the messages coming across, all the data coming across. So this is the unidirectional flow, right? One-way street. So simplex, remember, one-way street. Second is half duplex. What is this half duplex? Half duplex is the most common one that we will all use. So in half duplex, you see that the data transfer can take place in either direction. Okay, through the same channel, through the same link, it can happen bidirectional, but not at the same time. So in other words, if this particular station, let us call it station A, wants to send some data to station B, it can do so, but at the same time station B also cannot send to station A. It is bidirectional, but it cannot be at the same time. Full duplex is what? Full duplex is where there is no constraint on the direction as well as the time, right? So anytime in both directions, these two stations can communicate. That is full duplex communication. Simplex, half duplex, full duplex. So let me tell you that most of the communication networks that we have been encountering so far, or in this particular course, we will be talking about half duplex. Full duplex is possible nowadays, but full duplex is a topic of like advanced research. Okay, so there are a lot of research papers which are talking about full duplex communication, etc., etc., particularly in wireless, basically, in wireless channels, full duplex communication, etc. But half duplex is more common, right? So and it is traditional. Okay, so let us try to understand a little bit about these digital signals and analog signals. So what are the advantages of digital signals? So let us have a recap. These things actually are quite understandable, but let us have a recap in the context of communication networks. Digital signals can convey information with less noise, distortion, and interference. Advantage. All these noise. So you see when the data basically flows through, when the signals go through a particular channel, right? Due to various reasons, there could be different types of noise, right, which can be induced. Some noises are basically due to the movement of the electrons. Some noises due to the presence of some electronic or some electromagnetic device, right? So there could be noise, distortion, interference from other devices, etc. So those things basically are reduced heavily in the case of digital signals. Okay, so digital signals can convey the information with less noise, distortion, and interference. And in another lecture, we are going to talk more deep into what is this noise, distortion, and interference. Little bit further detail, we are going to have an understanding. So digital circuits can be reproduced easily in mass quantities at relatively low costs. So this is a very it's an advantage, right? So compared to analog circuits, digital circuits are more reproducible in low costs. Digital signal processing is more flexible because DSP operations can be altered using digitally programmable systems. DSP is more secure, digital systems are more accurate, and the probability of error occurrence is also reduced. Digital signals can be easily stored on any magnetic material or optical media using different semiconductor chips, and digital signals can be transmitted over long distances. So whatever I read for you, these are some of the different advantages of digital signals, and that is why digital signals are very popular in communication. However, they do have some disadvantages too. So digital signals require high bandwidth for digital communication when compared to the analog counterpart. If you really have to send some digital signal through the medium, right? So you need to really have these digital signals require higher bandwidth, and this is something actually that needs a little bit more discussion. Okay, so DSP processes, digital signal processing processes, the signals at high speed and comprises more top internal hardware resources. This results in higher power dissipation compared to analog signal processing. So digital signal processing basically releases more or dissipates more energy, more power compared to ASP, analog signal processing. And the processing in digital systems are typically more complex. Okay, so these are the things basically your friends who study in electronics departments, right? They understand these things pretty well. They understand these reasons, etc., because this is what they do, right? So for us, actually, we are simply mentioning over here these advantages, disadvantages, right? The way we have been told, but your friends who have a BTech in electronics, they really understand these things in pretty much clear way. So again, let us have looked through the advantages of analog signal. That was the digital. This is the analog. So here actually, the analog signals are easier to process. These are best suited for audio transmission, video transmission, because the data over there are also analog, right? So these are best suited for audio and video transmission. They have much higher density and can present more defined information. They use less bandwidth compared to the digital signals. This is very important, and this is something that we'll encounter again. So analog signals will require less bandwidth compared to the digital signals. Okay, and there are a few other different advantages also, right? So for example, they are less sensitive in terms of electrical tolerance. Disadvantages of analog signals: data transmission at long distances may result in undesirable signal disturbances because there is attenuation, etc. Attenuation means what? The signal strength basically reduces. So analog signals basically are not very advantageous in that sense. And analog signals are prone to generation loss. Analog signals are subject to noise and distortion. Analog signals are generally of lower quality compared to the digital counterparts. So these are some of these different disadvantages. Now, let us try to switch the gear a little bit and have a look at the complete total picture, right? Let us try to understand that a bit. So let us say that we are talking about two friends, right? Alice and Bob. Alice belongs to a particular organization which is called Sky Research, and Bob belongs to another organization which is, let us say, Scientific Books, right? They need to talk to each other. They need to, so Alice wants to send something to Bob, right? So get this picture in your mind, completely ingrained in your mind. So you see what happens. So so this is basically the path that will be taken by the messages that are going to be sent from Alice to Bob. But how? So in between, so let us say that Alice has a local area network like this, which has a switch or whatever. Then the data comes beyond the organization. It comes to a wide area network, okay, belonging to some ISP. Then there is maybe a national ISP like this, so where there is a switched WAN in this manner. And finally, it comes to a smaller ISP closer to Bob, and finally the message gets delivered to the local area network of Bob. Okay, so these are basically the LAN switches. This one and this one are the LAN switches, and these ones are the WAN switches. The R1, R2, R3, etc. All of these R's are basically the routers. So I already told you in the last class, not today, yesterday, that there is a concept of switch, there is a concept of router, and the switch and the router, they basically function in different ways. They are not the same thing, and they function in different layers. So let us try to understand that how this communication is going to take place between Alice and Bob. So for this, our focus today is going to be on something called the physical layer. And as I told you, these different layers I am going to introduce to you in the next lecture next week. So let us try to understand that how this physical layer communication takes place. So the device in Sky Research, all the devices in Sky Research, their physical layers are going to talk to the physical layer of this, let us say this particular layer, right? So the physical layer over here, so the physical layers over here, the physical layers over here, the physical layers over here, the physical layer over here, and the physical layer. So all of these physical layers, basically, they are going to talk to each other. So what is this physical layer doing? So this physical layer is concerned about the transmission of these signals, whether it is analog or whether it is digital. The physical layer is concerned about it. So our focus, whatever I told you so far, will be on the physical layer, right? So let us try to understand a little bit further. Keep this particular picture in mind while I proceed further. Okay. So few definitions which you need to understand, and if you have a pen and paper handy with you, please note them down. So first definition is about baseband transmission. What is baseband transmission? So baseband transmission implies sending a digital signal over a channel without changing the digital signal to an analog signal. So digital signal will be sent through the channel as a digital signal. So this is called baseband transmission. This is a term that you will be often encountering. So you see that you have a channel over here. So whatever I told you, this computer basically sends some digital signals. These digital signals will have to transmit through this particular channel as digital signals. You cannot really convert to the analog form. This is called baseband transmission. So two other definitions will come in very handy for you. So the second one, you please note down, I do not have a slide for it. It is called the concept of low pass channel. Okay, so channels can be of two types, right? One is called so one is called the low pass channel. One is called the low pass channel. Okay, the other one is called the band pass channel, which which I am going to talk about later on. Okay. So this this low pass channel basically is required for baseband transmission. For baseband transmission, you need to have a low pass channel. Okay, a low pass channel is one with a bandwidth that starts from 0. The bandwidth that starts from 0. Okay, so this basically happens if we have a dedicated medium with a bandwidth constituting only one channel. So for example, the entire bandwidth of a cable connecting two computers in one channel. Okay, so this is basically an example of it. You may also have another example where several computers would be connecting to each other through a bus network, right? Through some bus, basically, they will be connecting to each other. They will be, communicating communicating with each other. But they will not allow more than two stations to communicate at the same time. Okay, so again, we have a low pass channel, and we can use it for baseband communication. Okay, so this one I am not going to go too much deep, because in this particular course, actually we do not want to spend too much of time on the physical layer, right? So here actually, because this course is offered from computer science department, our focus is on the higher layers, right? But just, so that you have some basic understanding, I am mentioning these things. So this is the low pass channel. So what is the other type of channel? It is called the band pass channel. It is called the band pass channel. So you please note it down. You please write it. So I am dictating. So what is a band pass channel? It is a channel with a bandwidth that does not start from 0. So low pass channel, the bandwidth starts from 0, and in a band pass channel, basically the bandwidth does not start from 0. Okay, so this type of channel is actually more prevalent, more available than the low pass counterpart. Okay, so now we need to really understand that how you are going to have this transmission, okay, through low pass channel, baseband transmission through low pass channel. Okay, so with the help of modulation. Okay, so modulation of a digital signal for transmission on a baseband, on a band pass channel. This is what we need to understand through this particular figure. So here actually, if you are talking about a digital signal, what did I tell you? That the digital signal, if it has to go through the band pass channel, there are certain, it cannot be sent simply like that. It cannot be sent simply like that. Okay, so it needs to go through certain processing. Okay, so the input digital signal will first have to be converted to the analog form, right? Then that input analog signal bandwidth, so the input in an analog signal will then have to pass through this particular channel, right? And then the same thing goes on all the way up to the recipient, right? So there is the output digital signal like this. So you see, through the channel, basically this input digital signal will have to be converted to the analog signal, right? It will have to be modulated, right? So how does this conversion and the modulation basically happen? This is something that so in next couple of lectures, basically we are going to talk about, right? So there are different forms of modulation and so on. So this conversion also, how it is going to happen, but we are going to touch very briefly. So for students, basically, let me just tell you something, that this particular part, because so we are not covering too much from the physical layer. So physical layer, in the book by Faruzan, 5th edition, so this is basically section 3.3.4, 3.3.4, transmission of digital signals. Okay, so this particular section you need to read, okay, and get yourselves convinced. So 3.3.4, transmission of digital signals, okay, from the book by Faruzan, 5th edition. Okay, so now let us try to understand a little bit further. So let us say that so we are required to we have a problem like this, right? So let us say that we have a problem like this. The question is that what is the required bandwidth of a low pass channel if we need to send 1 Mbps by using baseband transmission? So can someone, without looking at the book, can someone please tell how you are going to approach this problem? So for this, Okay, so it is difficult for you unless you already know. It's not expected that you will be able to tell. So that is the reason actually I asked you to read the section 3.3.4. So let me give you a couple of information which will be helpful for you. So I hope that all of you are writing on a piece of paper. So first thing that you need to know is that the baseband transmission of a digital signal that preserves the shape of the digital signal is possible only if we have a low pass channel with an infinite or very wide bandwidth. So if we are talking about a low pass channel, you can send the digital signal, okay, only if the channel has an infinite bandwidth. So in other words, basically it is not really possible to send the data through a low pass channel. Okay. So for this, basically, you need to do some approximation of the digital signal. Okay, so the digital signal that is coming through, you need to approximate it as an analog signal. Okay, so you need to convert the digital to analog, right? So for this, actually, you need to make certain conversion. So this conversion is basically results in an approximation, because the digital signal, how does it look like? It looks like, up, down, and so on, right? So let me see if I can, I kept some slides for you over here. This is how a digital signal looks like, isn't it? A digital signal basically looks like this. So this is basically, so if you want to encode zeros and ones, right? So this is how the digital signal is going to look like. And there are more sophisticated ones with not just two levels, where you can have multiple levels, right, which can be encoded, through which it can be encoded. So for example, 1 1 1 0 0 1, like that, so you can show these things like this. So again, so I don't want to go too much deep into these things, but these different levels of digital signal I am going to touch upon also in another class, right? So that it becomes a little easier for you. Now, so the question, let me see here. So you see that what we need to do is like this. So let us look at a digital signal like this, right? So you see that this digital signal, if you have to send it as an analog signal, what you need to do? You need to approximate it this way. You need to approximate this digital signal in a certain way. Now, if you are talking about a digital signal like this, the closest approximation you are going to do will look like kind of a sine curve, right? And the sine curve, it will have different shapes with different frequencies and different periods, depending on the bits that are being transmitted. So you need to do certain approximation. So how this approximation is going to happen? For that there are different approaches that are there. So we are not going to touch upon those approaches too much. But for you, again, section 3.3.4 in Ferguson 5th edition, please have a look. You try to understand how these approximations can be done in a naive way and in a better way. Okay. So, but what I would like to tell you is that if you do a rough approximation, okay, the required bandwidth for transmission is basically, this is a result, it is going to be n by 2, where n is the bit rate. This is the result, but this result, how this approximation is coming, this is again an approximation only. How this approximation is coming, I would urge you to read the book. So the result is the bandwidth is n by 2, where n is the bit rate. Okay. And another result I would also like to mention at this juncture is that in baseband transmission, the required bandwidth is proportional to the bit rate. If we need to send the bits faster, we need more bandwidth. That's all. Fair and plain and simple. Okay. So now let us go back and try to try to understand whatever I was doing over here. Now you see that the required bandwidth is n by 2, right, through some approximation. Now the question over here is, what is the required bandwidth of a low pass channel if we need to send 1 Mbps by using baseband transmission? So here actually we are talking about baseband transmission only, right? So baseband transmission we need to do through a low pass channel, right? And we have 1 Mbps. So can somebody tell me, like, what will be the required bandwidth? So what is the data rate? N, what is the value of N? I told you that the required bandwidth is going to be N by 2. That is the result, the final result, right? So what is N? N is the data rate. What is the data rate over here? 1 Mbps. 1 Mbps is the data rate. And I hope that you know these units, right? So Mbps is megabits per second, right? So 1 megabits per second. So now see, look at the answer, right? So the minimum bandwidth through the rough approximation is B equal to N by 2, where N is the bit rate. So if the bit rate is 1 Mbps, so this is going to give you 500 kilohertz as the answer. So the required bandwidth, the minimum bandwidth through the rough approximation mechanism is going to be 500 kilohertz for an 1 Mbps data rate. So we need a low pass channel with frequencies between 0 and 500 kilohertz for the transmission of this, this particular signal. Now there are some better approximation mechanisms that are also there in your book that can be achieved by using the first and the third harmonics with the required bandwidth. So B is going to be not N by 2 but 3N by 2 and 5N by 2. Okay. So N by 2 is the first harmonic. So through better approximation, you can have B equal to 3N by 2, which will be 1.5 megahertz, and 5N by 2, which is going to be 2.5 megahertz. Okay. I know that this part actually is will become confusing to you, but actually, so I don't want to delve too much of time on this. I would urge you to read that particular section which I mentioned thrice today, and then things are going to be somewhat clearer to you, right? But remember that these are like huge topics that your friends in electronics and data communication departments, that they spend a lot of time on, right? So they understand these things pretty much well. Okay. So for us, we are just going through only the very basics that are required for you to proceed further. Okay. So let's go ahead. So we need to have broadband transmission, right? So broadband transmission or modulation basically means that you need to change the digital signal to the analog signal for transmission. Okay. So modulation basically allows us to use a bandpass channel, which I already told you is a channel with a bandwidth that does not start from 0. Low pass channel, the bandwidth basically starts from 0, right? So if you look at the frequencies, it is going to start from 0 to f in a low pass channel, and if you are looking at the frequency range in a band pass channel, it is going to be between f1 to f2, right? So so between two different frequencies, fixed frequencies, not starting from 0, the band pass channel frequencies are going to be, right? So essentially the bandwidth is not going to start from 0. Okay. So now, so let us again, switch our gears once more. So now let us go back to what I was telling you, that the signal, when it passes through the medium, it does not remain the same. It gets affected by the medium. Okay. So essentially the signal at the source and the signal that is received at the destination through the fixed channel it's not going to be the same. The signal is going to be affected in different ways. What are these impairments that are going to happen? One is attenuation, the second is distortion, and the third one is noise. These are the different causes of impairment. Attenuation means like the loss of energy. The signal, every signal, a pulse basically contains certain energy. It has certain associated energy. So when that signal travels through a particular medium, it is natural that it loses energy to overcome the resistance that is offered to it while passing through the medium. It is going to lose some energy. So essentially what is going to happen, if the signal strength is going to be lost after traveling for a certain time, you need to boost it up in certain ways. So there are certain devices like repeaters, etc., which can basically help in rejuvenating these signals. So so you need to basically compensate for this loss. You need to compensate for this loss with the help of amplifiers that will amplify the signal, that will increase the strength of the signal. Okay. So to show the loss or gain of energy, the unit that is used is decibels, dB, small d, capital B, decibel. And I think because you have studied physics before, you must be familiar with this term dB, right? So you see that from point 1 to point 2, you have this signal which is transmitted. Now when it arrives at point 2, the signal is attenuated. That means it has lost some of its energy. So now if you let the signal pass further, then basically the information that is encoded in this particular signal, it is going to lose that information. That information is going to be lost. So you need to boost it up with the help of this amplifier. You need to boost it up with the help of this device, which is the amplifier. This amplifier basically from point 2 to point 3, you see if you have an amplifier, this amplifier is going to again give it some more energy and it is going to come to its original form. Okay. So this is basically the attenuation. Now let us try to understand the term distortion. Distortion means that the signal changes its form or shape. Okay. Now if you are talking about composite signals, again this is something that I assume that you already know, or in case you do not know, in your book it is mentioned what is a composite signal. So if you are talking about a composite signal like this composite signal can be broken into its different components like this. So a composite signal is basically comprised of these signal elements like this. Okay? So these are the different components, signal components like this. Okay. So this is at the sender. So this composite signal has its different components at the sender in this form. Now at the receiver, basically this composite signal, okay, it can get changed to have a different shape or different form, right? So this composite signal will change its form or shape in this manner. So now if you again break it into its different components, it is going to be like this. Now you see the components from the sender and the components from the receiver, if you look at, there is a difference. So these components are in phase, whereas these components are out of phase. And this is quite visible, right? So like from your physics, basically physics knowledge, right? So these components are out of phase. So you see this composite signal in essence gets distorted at the receiver end in this fashion. So this is called distortion. Now what is noise? noise is some kind of unwanted electrical or electromagnetic energy that degrades the quality of signals and data. So how it can happen? There are different types: thermal noise, induced noise, crosstalk, impulse, and so on. So I would urge you to try to understand all these different types, but let me try to understand, explain to you what is this noise. So unwanted electrical or electromagnetic energy, right? So you have some, additional energy due to whatever, so due to the presence of some other medium, some electromagnetic device, some other medium or whatever, which basically, so if you have a transmitted signal like this passing through the medium in this manner, the noise comes in as a signal. Noise is also a signal, right? So this noise comes in as a signal and it basically degrades the quality of the signal in this manner. So if this is the transmitted signal, due to the noise, the signal quality, okay, is changed over here at the receiver end. It is degraded at the receiver end. So these four types of thermal, induced, crosstalk, impulse, I would urge you to understand yourself. So thermal, let me tell you, thermal is due to the movement of the electrons in the medium, right? So movement of that is the thermal noise. So similarly, you have the induced, crosstalk, impulse, which are also like, so one of these is due to the presence of like, electromagnetic devices, etc. So like that, actually all of these different types of noises are there. So you would have to go through them yourself. Okay. Now, okay. So this is so noise basically is some form of impairment. Noise is some form of impairment. Okay, and yeah, so crosstalk basically, I think most of you are already familiar with crosstalk, right? So before I proceed further, I just wanted to touch upon this crosstalk. So crosstalk basically, it happens due to the presence of another medium, right? So if you so if there is a transmission that is going on in one wire, and the presence of another wire basically induces this crosstalk. So one wire basically will act as the sending antenna, and the other one is going to act as the receiving antenna in that case. So that is where this crosstalk basically comes into picture. And impulse noises are basically spikes, etc., right? And induced noises, as I already told you, due to the presence of some other electromagnetic device like motors, appliances, etc. Okay, so this is basically the noise. Now another terminology that you will encounter quite often is called the SNR, signal to noise ratio. It's a very important metric that is used to define the quality of the signal. Because every signal that goes through certain medium is basically vulnerable to getting affected by noise. Now the signal to noise ratio basically indicates the strength of the signal with respect to the strength of the noise. The strength of the signal with respect to the strength of the power of the noise. Okay, so you see that it's a ratio between the two signal strengths, strength of the signal by the strength of the noise. SNR, signal by noise ratio, signal to noise ratio, and it is usually given in decibels and represented like this, SNR dB. Okay, so it is represented like this. So here you see that if you have a noise, so this leads to a high, so this is a signal, a large, it's a signal, and it is affected by this noise, and how this signal plus noise is going to look like. And here actually you have another signal, and it is getting affected by noise. So how the signal plus noise is going to look like. So this is just a visual representation, but so what what we will be concerned about is not the visual representation, but this ratio, right? So S by signal strength by the noise, right? So S by R, sorry, S by N, right? So that is this ratio that is important. So average signal power by the average noise power is this signal to
Sir, you are not audible.
Okay, got disconnected again. But I think what we will do is we'll stop over here because we have already completed time. The only last thing that I would like to mention is the SNRDB, right? So SNRDB means like SNR in decibels. The formula to calculate this signal to noise ratio in decibels is basically 10 log to the base 10 SNR, right? So 10 log to the base 10 log to the base 10 SNR, right? And SNR is average signal power by average noise power. Okay, so this is the formula that is used. Okay, so that's all. Do you have any question, any quick question? Because so we are already over time, but I would still like to see if you have any questions. And there are a lot of other interesting stuff that is coming along. And next class, actually, we are going to cover those. I know that I am actually quite delayed, but I still didn't want to skip much and want to cover these things in a little bit of detail so that my intention is that you should feel well equipped at the end of the course with computer networks. Okay, so any question, quick questions? Okay, so if not, so thank you, and please make sure that you start reading the books as well. The slides will be up on my website, and the links are going to be posted on Teams, and these files are all going to be password protected. So the corresponding password is also going to be mentioned on Teams. Okay, so thank you, all the best. See you next week.